Yeah, okay. So my name is Ahmad Mardiansyah, and then I'll be talking about quality of service on Mikrotik in this webinar. During the webinar, sometimes I'll be turning off my video just for saving the bandwidth. Okay, because we are talking about bandwidth, so we need to do uh, some actions or something that reserve the bandwidth. Okay. Right, so I'll be turning off. So hopefully you can see my face. This is me. Okay, I'll be talking about the what you are seeing on your screen tonight. Right. Okay, let's get started. Um, okay, so um, today we'll be talking about the quality of service. Right. Okay, some of you are from Indonesia. Some of you are not from here. Okay. So is there anyone from Taiwan or Australia? It must be very late over there. No, I don't see here some. Okay, nobody. Okay, that's fine. So most likely people are from Asia, most likely west part of the Asia, maybe from Middle East or from India. I can see Bangladesh or uh, yeah, that kind of area, or maybe some of you are from Africa. Yeah. So today we'll be talking about quality of service. This will be our agenda. There will be we're going to have an introduction and then QS fundamental, Linux QS on Mikrotik, and then if time permits, we can do live practice so that you can log in and then we can do something on our Mikrotik. Okay. Oh yeah, somebody from Singapore here. Thank you guys. Uh, yeah, okay, let's get started. So this is our agenda. Okay, introduction. So we are GLC, Garda Lintas Cakrawala. We are based in Bandung. Our areas are IT and IT consulting and then training. Okay. Okay. We are certified partner for Mikrotik, Ubiquiti, and Linux. We also do developer programming things. We develop our own products. GLC billing manager. It's GLC radius. We sometimes we call it GLC radius. Basically, it's a platform to yeah, it's a platform to manage your own billing and then the user if you have organizations like ISP. Next is about me. My name is Achmad. As I mentioned before, I'm based in Bandung. Linux user since 1999. Mikrotik since 2007. Ubiquiti 2011. Mikrotik certified trainer, consultants, and website contributors. You can find my info, more info about me on LinkedIn. About past experience, uh, we had a project in Malaysia about IoT integration, then network automations also built a billing solutions for them. We also have project in Congo. We built a wireless ISP from ground up. Uh, in Libya, North Africa, at that time we were doing the wireless migrations for the new ISP. Actually, they already have a network, and then we came and then do some configurations. In United Kingdom, we also do workshop and then do maintenance of an ISP. And in Kalimantan or Borneo, we support a wireless infrastructure project. About the webinar itself, we first started in 2010, so 10 years ago, in the new year. At the time, we have nothing to do. So, okay, let's do a webinar. Okay, that was our first webinar. We talk about the Solaris operating system. So, because I'm based, I was a Linux guy, and previously working in the telco as a system administrator, engineer. Okay, so most of the time, every day, almost every day, we do dealing with the Unix-based system, collecting logs, checking files, make sure the file, the servers are up and running, and then doing some troubleshooting. Okay, do the network analysis, take some packets out from the network for analysis, open the Wireshark, and then check the call flow, and then so on and so forth. So about yourself, I think you already introduced yourself. Thank you very much. I can see many of you are from Indonesia. Some of you are not from here. Okay, thank you. So I'll be speaking in English. And okay, here we go. We talk about QoS, right? So what is QoS? QoS is quality of service. It's a description or measurement for overall performance, such as service-based network. So anything that is based on networks like telephony, um, viewing videos over the network, computing service, usually is measured by QoS. So QoS is the standard definition to define how good is your service. Okay, so for example, we have, so yeah, actually this picture, I think it's too early to be put here. Okay, later on, yeah, I just thinking it now. It's too early because this slide is talking about QoS, the early definition of QoS, and then this one is quite advanced. So just ignore the picture here. Okay, so the thing for the QoS here is the measurement of the performance of a service. So you have service, okay. So you have service here, and then you want to measure the performance of your service, right? Okay, so that's the definition of QoS. And next questions. Do you need QoS? Okay, so most likely when you are accessing the network, you will be using a so you'll be accessing the network, and of course for by doing that you are consuming a bandwidth. Okay, uh, so this is the bandwidth. Okay, so that's the available bandwidth. Okay, the bandwidth that is provided by your provider, and then your consumption here. Okay, and then you will need QoS if your available bandwidth is less than your consumption. How do you know? This is the example, right? Yes, you can see flat like this. It means that you already reach your own capacity. You already reach the maximum capacity of the available bandwidth. Okay, so that's why you need QoS. Okay, as simple as that. So that this is when you. I am sure all of you must have a monitoring system like this, which can shows uh, a nice graph like this, which can shows the amount of usage at a certain amount of time. Okay, uh, can be one day, last 24 hours, last 48 hours, and so on and so forth. So based on those graphs, you can see how much is your consumption. Okay, if your consumption is quite high, which can be, you can see it here, you can see it, there is a flat line, flat graph like this. Usually your consumption already reached the maximum capacity of your uh, of the capacity that is provided by by the network, okay, by ISP, by your ISP. So you are a customer, and then you subscribe service to an ISP, and then this is the bandwidth consumption graph, right? So is there any chance that you don't need QoS? Oh yeah, here. Okay, so oh, I think this slide is not updated yet, so I need to refresh. Please wait. Okay. Okay. So can you see the slide now? Yeah. Okay. So first is when you don't need QoS. Okay, this is the first question. So I put the sequence. The sequence was not updated, so it has to be like this. So the first question is when you don't need QoS, when you have enough bandwidth for your consumptions and no customer complaint from the customer, and then if you already have all of them, and then you are welcome to quit this webinar. Okay, you don't need this webinar, right? Okay, so I can see here we have 40% coming. Okay, that's fine. If you have this experience, you already have enough bandwidth for your own consumption and no complaint from the customer. Come on, guys. I mean, better you quit from here. Right. So, okay. So I'm waiting. So we have 40% now. So is there somebody leaving? Okay. I'm waiting. Nobody. Nobody, guys. So you still have. I mean, if you are from, yeah. Okay. If you are from ISP, okay. And then if you experience like this, no complaint, and then that's fine. If you are subscribing to an ISP and then no complaint from your employees, for example, if you are working in a company managing their network and then no complaint, that's fine. Right, so nobody leaving. Right, so you guys need the QoS then. So it means that your consumption, your available bandwidth, is less than your own consumption. Okay, so you have a big consumption, but the available bandwidth is not enough. Okay, so I mean it's a classic issue, right? Similar like money. You have lots of you have unlimited uh, you have unlimited uh, uh, you have limited money, but you have unlimited desire, which uh, yeah, which is if it is quantified, it requires more money than you have, right? Next. So what will QoS do? Okay, so QoS will do sometimes QoS will do a limitation. Okay, so limitation. So it will limit. Oh, okay, please make sure you don't limit this amount of maximum capacity. So for you guys, for example, for customer number one, I will give you 1 Mbps, 1 megabit per second. And then also that's the maximum limit here. And then sometimes we also provide a minimum guaranteed limit. Besides limitation, we also do priority. For example, this often uh, happens in the telco. For example, if you buy expensive package, most likely the speed is higher than the other package. Why? Because it's more expensive, right? Like in here, we have XLCom. They have a hot rod packet, which is quite more expensive than the regular packets. But when you when yeah, the 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 volume or the quota is the same. For example, 2 gigabit per second, 2 gigabyte volume. Okay, so I'm talking about volume. Okay, but their speed limit is higher. Okay, so why is it higher? So that you can spend the quota as soon as possible. After the quota is finished, and then you have to buy again, which means more money. Right. Sometimes we also provide bursts. So burst means we give you amount limitation more than max limit. So this is the time, okay, and then this is the bandwidth, okay, and this is your maximum limit, okay, max limit here, for example, 1 Mbps, okay. So with burst, we will give you a burst speed, for example. This is burst, okay. So the speed would going to be like this, and then turn. So only happens, for example, uh, five 5 seconds. Okay, so for 5 seconds, actually your maximum is 1 minute. 1 Mbps, 1 Mbps. But the burst can be go up to 3 Mbps. Okay, I forgot to mention that we have. Okay, I forgot to make the slide of it. So actually the burst here, uh, before we go to burst, okay, so there are two kinds of traffic. Sorry, I forgot to put here on the slide. I forgot to make the slides. I just remember it now. So traffic, there are two traffic. First is steady traffic, and then burst traffic. Okay, steady traffic is, for example, streaming. Okay, streaming, download, and then so on and so forth. So steady traffic means call, sorry, VoIP call. Okay. So steady traffic always consumes steady consumption. For example, always consume 1 Mbps. Okay. So when you are angry, when you are not speaking, when you are speaking slowly, when you are happy, whatever, you only consume 1 Mbps when you do VoIP call. Doesn't mean that when you are shouting over the phone, doesn't mean the usage or the traffic increase to 2 Mbps or 3 Mbps. No, it's not like that. So it's always steady. Okay, stream. Okay, sorry for my bad handwriting. So the second traffic is for bursts, for example, web browsing. Okay, web browsing, messaging. Okay, email. Okay, and so on and so forth. Okay, so this burst is intended to burst traffic. Okay, so burst feature is usually for burst burst traffic. So there are two kinds of traffic. Okay, I'll repeat again. Better if I erase this. So there are two kinds of traffic: steady traffic and burst traffic. Okay, bursty, just like explode. Okay. Okay, so if you have any questions, just put them on the group chat. Okay, we'll be discussing the questions while I'm presenting the materials. Okay, somebody have an audio problem here? No. Okay, no. So please turn off your microphone. Okay, just listen to my voice. Right. So that what QS do on your network if you have QS. Next thing is, how do you measure QS? There are several parameters here. First is packet loss, okay, and then throughput, how many Mbps, right? And then latency and jitter. Okay, so packet loss means, yeah, the packet is lost. I mean, because you already reached the maximum capacity usually, yeah. Okay, max capacity is reached, and throughput, okay, for example, 2 Mbps, okay, so you can see it on your what is it, speed test, okay, so they will also check things like that. And then latency, okay, ping from here to there, it's round trip time from your laptop back to your laptop again. And then jitter is variance of latency, but that depends on the applications, okay. Sometimes this application okay, that application is not okay. So sometimes people don't care, right? That's the annoying part of being network engineer. Sorry for that. So this is our own. So I just take a picture for my Zoom conversation here. This is the frequency. I mean, nothing to do with the. Sorry for that. Nothing to do with the QoS. Okay. So the things like latency here and jitter. Okay. So latency 100 milliseconds. Okay, that's fine. So hopefully I hope that could be less than 100, but 100 millisecond is okay. Right. So I have. So there is one question here. Is there any video recording? Yes, we'll be posting the recording on our website. Attendance info. Sorry, I don't understand what you mean. Okay, so that's how you measure the QoS. And then actually, when we talk about QoS, there is another parameter is called QoE. And this parameter is much more important than QoS. Okay, it was defined by the ITUT, which shows you the degree of delight or annoyance of the user of an application or service. Okay, so when we talk about QoS, we talk about technical things here, but when we talk about QoE, we talk about end to end of the customer experience, right? And then QoE, it is quite hard to measure, okay, because not always technical. Sometimes, yeah, it's QoS is a part of QoE, of course, okay, but it's not only that, okay, it's involved humans, psychology, context, and so on and so forth. Okay, but in this webinar, we just talk about the QoS. So next question is, okay, you have, because most of the service now are based on internet, right? So how can you, is it possible to provide end-to-end QoS? Okay, just like this. So internet actually is a collection of network. Okay, so can you guarantee QoS? Yeah, that's the point. Okay, I don't think you can do that because QoS, you can apply QoS if that network is on your administration, right? For example, this is yours, okay? This is your ISP. And then you connect to this, you connect to that, you connect to this, you connect to that. Maximum you can do is you can do a guarantee a bandwidth in here, right? Okay. So how can you provide a guarantee to connect to Google? Here, this is Google. This link, okay, I use other colors. Okay, let's do this one. So this, oh, maybe not. Hmm, maybe purple. Okay. Yeah. So this link and this link is not belong to you. How can you guarantee the QoS from your customer? So this is your customer, all right? Okay. Let's do. Okay. Let's do yellow here. So you have a customer here. Okay, customer, yellow customer. Okay, you have a customer connect to your own ISP, and then your customer wants to connect to Google. How can you guarantee Google? Well, it's difficult, right? Yeah. So maximum you can do is just a guarantee connect to give your customer guarantee that okay, you will consume this maximum of a bandwidth. That's it. To how? What about the bandwidth that goes to the Google? Sometimes you give them 10 Mbps, but when they access a Google, they can only get the 5 Mbps, for example, right? Because you cannot control end-to-end QoS. Sorry to say that, but again, customer doesn't care, right? We are so exhausted because of it. So that's your choice to become a network engineer or involved in the ISP business. Okay, so next about the Linux queue. So Mikrotik uses Linux kernel. So the queue happens in the on the interface. So what we queue, with we queue packets. Okay, so this is network interface card is the hardware. Okay, and then when we receive packets, and then the packets needs to be forwarded here, right? So on the way to go to the NIC physically, there will be a queue here. Okay, so if we are model it, yeah, I took a class about the network. What was it called? Network performance. Yeah. Actually, the course name was really appealing about network performance. Okay, in when I was studying overseas, but when I took it, we talk about the queuing theory. Queue theory. So we have a lambda, it means that the arrival rate, and then we have a waiting area here, and then we have a service node. But actually, in that course, we really want to model the queuing of that which can be applied in many areas. One of it is the network. Okay, so when you have a packet, and then the packets needs to be forwarded to other networks, and then we have a queue in between. So we have a lambda here, right? And then we have a waiting area or buffer here. Okay, buffer. Okay, so buffer, and then we kick the packets out from the physical interface. Okay, so that's how the queue in a Linux-based system. And what about the router? Yeah, it's nothing different. So as you can see, we have a router here, right? So we have a router, one router, okay. And then we have input interface inbound, okay. And then we have outbound, okay, here. So same, the queue can be done on the input inbound interface or outbound interface here. Okay, so same thing. So we have a queue, you have buffer, and then uh, we have buffer, and then the queued packet goes to the buffer and then kick out through the interface. Okay, next. Next is about queues on Mikrotik. So in Mikrotik, we have a packets flow. Okay, actually, when I check the packet flow, latest packet flow diagram, it's already changed. This one's still relevant, but it's not detailed. But I think it's enough to explain the queuing system, how the queuing happens on Mikrotik system. Okay, so when you use Mikrotik, there is a uh, yeah, there is a system like this. Okay, so this system is derived from the Linux IP tables, yeah, which has oops, which has a flow like this. Okay, So you have an input interface, and then from the input interface, you go to pre-routing chain, okay, from pre-routing, and then you go to routing decisions, which is IP route print. You can check it there, okay, and then it will decide whether it goes to input or forward. Okay, if the packet goes to forward, it means the packet is just passing through the routers. Okay, it will be forwarded to post routing and then goes to the output interface. Is it possible that input and output interface are same physical interface? Yes, that's possible. Okay, yeah, so this is how the packet flow looks like on Mikrotik. So the packet will be queued on input and on post routing. So these are two places where we queue the packets. Again, what we queue is the packets, even though all of them are bits, but when we queue, we always queue the packets, and then we never change the order of the packets because it's gonna be very, very messy. Okay. Your application, you know, you have a, you remember when the yeah, there is a reassembly on TCP, right? So we have a TCP and then we have reassembly. Then we have to make sure that the data arrive on order. If not, and then we have to reassembly, we have to wait for the packets, reassemble, and then send it to the upper layer, right? So here, when we do queuing, okay, we never change the order of packets, okay, order of packets. Order means the sequence, okay, sequence packets. So packet A arrive first, and then after that is packet B, packet C, packet D. So Mikrotik never changed the order of the packets, okay, only queue them, okay, right. So about bandwidth management mechanism. So Mikrotik uses HTB. Oh, so Mikrotik uses HTB, hierarchical token bucket, for managing the queue. So as you can see previously, we have a queue, we have a buffer, and then on that buffer we use, I mean, Mikrotik uses HTB, hierarchical token bucket, and then we apply algorithm on that. Okay, some algorithm are FIFO, first in, first out, random early detection, SFQ, and PCQ. Okay, so how the HTB looks like? Well, it looks like this. So Mikrotik provide a very nice a picture about HTB so that we can understand it clearly, right? So when we see this diagram, we have three colors. Okay, so the first color is I don't know. I'm seeing here is, this is not red. This is like orange, dark orange, I think. So this part is the algorithm, okay, and then yeah, it's the token bucket algorithm, and then the buffer happens here, okay. And then the black color here, oh, make it very messy. And then the black color, this is the algorithm, and then this is the queue, and then here is the uh, rate selections, rate, okay. So this is how it looks like. Yeah, so when packets arrive, yes, the packets, and then we check, is the queue full or not? Okay, so if the queue full, and then we drop the packet here. So the packet drops after the queue is full. How do you know queue is full? And then we can check it here. Okay, so it's, yeah, it depends on the algorithm. Okay, let me click them all. Okay, let's pick another color. Okay, maybe green. Yeah. So this is queue size. Okay, so when the packets arrive, the queue will be filling up here. Okay, and then it always check. Okay, is there any token available? If there is a token available, we take the token and then put them in the queue. Okay, the process is very fast. Okay, so it happens in maybe in nanoseconds. Okay, and so that's how it works. Okay, so packets coming. Okay, packets coming to the queue, and then if the queue is full, we drop. If the queue is not full, and then it's pass. Yeah, very simple. Okay, so that's how the queue works. Next is about how the uh, how the token is done. So we have a token bucket here, okay, which has, for example, 1 Mbps. Okay, so 1 Mbps. That's the token bucket. So we check. Okay, so we check 1 Mbps. So 1 Mbps means so it's a 1 million, right? 111. Sorry, 100,000 bits. Okay, bits per second. Bits per second. Okay, 1 bits per second. And then how can we translate this into packets? Okay, so that's why we need to do assumes. We need to have an assumption that one, for example, one packet is, uh, for example, it depends on the MTU, right? So MTU is 1500. Okay, 1500. What's the units of the MTU? Bytes. Okay, bytes, not bits, bytes. Okay, this one is bit, this one is byte. So it means we have to multiply to 8. Okay, so 1500 multiplied by 8 equals to, wow, need to check. Can anybody help me with this? Can you put it on the chat box? Okay, I'm taking a calculator. Okay, so 1500 multiplied by 8 equals to 12,000. Okay, so 12 12,000 bits. Okay, 12,000 bits. So that means so we just assume that all packets are in the full MTU. It's 1500 bytes or 12,000 bits, right? Okay, so it means that in 1 second we have 1 million 1 million divided by 12,000. So how much is it? Okay, so equals to 83.3 packets. Yay. Okay, so this is the number. Okay, so how many queues? Okay, it's 83 packets. So if we have already 83 packets here, so when another packets arrive, and then the packet will be dropped. Okay, 83 packets. 83 packets. Okay. Oh, right. Thank you. Yeah, 12,000. Thank you. I just read the chat. Yeah. So this is how it looks like. Okay. So one bucket. Okay. The rate limit is there any limit available? Yes. And then we convert all of them into a token, right? Token. This is the token. So we convert everything to token, and then when a packets arrive, and then the token is taken here, and then the token will be decreased, and then the queue buffers also filled up here, will be filled up, and then if the queue is full, and then the new arrived packets will be dropped. So that's how it works. Okay. So it's a little bit messy, but yeah, I think you get the idea. Right. So somebody is saying something. No? Okay. Please turn off your microphone. Okay. Otherwise, I cannot hear you clearly. Next is about the queue size. Okay. So when we define a queue, we define the buffer, right? So the queue size here is the buffer. Yeah, queue size, right? Queue size. So if the packets are limited, the token is limited to, yes, token. We convert the capacity into tokens. Let's say one token is one bit, for example. Okay, and then when the token is taken, and then the token bucket will be decreased. Right. Next. Yeah, so this is the queue size. Okay. So we already put the maximum limit of the buffer, right? So sometimes when we have a maximum limit here, for example, so this is our maximum limit, right? So this is our maximum limit. So when we put the rate limiting, it means that we just drop the packet. So the packets here, okay, the package here will be dropped. So it's going to be like this. Okay, so nothing here. Okay, so we just cut the packet. So when the packets arrive, the new packets arrive, and then the buffer is full, we just drop it. Okay, but second mechanism, we can do scheduling. Okay, so it means rate equalizing. So that means we reschedule the later arrive packets. Okay, so we can see here the buffer here is also already full. Okay, buffer is full, but the newly arrived packets will be saved into a buffer here, and then later on, when the packet is not when the what is it when the queue is not full, okay, we send the remaining packets on the buffer here. So we just reschedule the descending. Okay, so we not drop, we reschedule. So that's just one technique how you can implement the QS. Okay, either you use you're using the limiting or shaper or rescheduler. So that one in on Mikrotik, you can define it by defining the 0 or more than 0. But beware that if you're rescheduling too much, okay, you're rescheduling too much here, and then there will be a delay increase. Okay, because yeah, I mean, you're scheduling the sending. Okay, the sending process of the packets, right? So just for your information, just I mean, be aware of when you define the queue size too much. Okay, it will, I mean, on the effect of that decisions usually can lead to the higher delay. Next. About the queue type itself, you can see it on queue and queue types. So we can see here FIFO, okay, B FIFO. So P FIFO means packet FIFO. FIFO means first in, first out, or B FIFO means bytes. So instead of packets, we convert it into bytes. And then we have PCQ. PCQ per connection queue. We have RED, random early detection, and then we have SFQ, stochastic fair queuing. So actually, the SFQ is updated and become the PCQ. So PCQ is more advanced. So I would recommend to use PCQ for your network. And this is how you uh, use the queue. Okay, right. So this is how you use the queue. For example, in Mikrotik, we have two types of queue. First is queue simple. This is how it looks like. So you just put the name and then the target and then put the maximum limit, and it's very simple. Okay, so the target can be a group, for example, this one, okay, or can be targeted on. Uh, you can put a target on individual IP address. Okay, yeah, it's very simple. And also fast processing, especially on multi-core routers. And then when you check the advanced tab here, you can provide a limit at the minimum guarantee that you guarantee to the customer. So at the minimum, when we have a minimum, when you have a situation where all bandwidths already full, you already reached the maximum capacity, and then this is the maximum, sorry, this is the minimum uh, limit or bandwidth that the customer can use. Okay, and then here you define the queue type. Okay. Also, you can use burst, but remember, okay, this is the burst of this queue. It doesn't mean that okay, I will use burst if the customer, if, for example, this is your ISP, right? ISP, and ISP only give you 10 Mbps, and this is your router, right? And then here's your customer, right? Customer, 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 customer. Okay, when you give burst only happens on your customer, okay, not you, okay? So it means that when you already reach 10 Mbps, you just eat 10 Mbps. Even though you put a burst here, it doesn't make 10 Mbps to become 20 Mbps. No. So I often, sometimes I got that questions, not questions. Yeah, the questions, some cases. Okay. So when I do a burst here, when they do apply burst, the burst is not is not uh, working as they expected. Well, because the burst again only works on bursty traffic. Okay, burst here only works on bursty traffic. Bursty traffic. Okay, for steady traffic, no, doesn't matter. Okay, so that was the simple queue. And then if you have more advanced, if you use more advanced um, case, yeah, you can use Q3. But in order to use Q3, you have to do some mangles and do queuing for that. Okay, so I think Mikrotik is one example, is one vendor that has uh, has advanced features of QoS. Okay, other vendors, I don't think they have features like Mikrotik has, and then it works okay, right? As long as you understand how the queue works. Okay, the queuing on Mikrotik can be useful for your network. Right, so I think we can do a live practice now. Okay, prepare. I have prepared an address here so that you can check. So first, you have to log into our server. Here it is. Okay, you can try and then follow my instruction. Okay, I will share my desktop. Okay, I got one question here. What if the burst already reached the maximum limit? Well, the burst is higher than maximum limit. Okay. So for example, the maximum limit is 1 Mbps. The burst is always higher than that because that's the purpose of the burst, right? The purpose for the burst is to give an impression for your customer that your network is faster. But only happens in few seconds, for example, 5 seconds or 10 seconds. And after that, it goes to the max limit. Right, so I'll be sharing my desktop here. Oops. Oh, why cannot share my whole desktop? Hmm. Okay, I will share my a shell here, a terminal. Okay, so this is a SSH connection. So you can use a SSH client like PuTTY. Okay, so what you can do, so I'm using Mac, and then Mac has its own terminal, so that I can do like things like this: SSH, live practice, and then the port is the one that I give you, right? Password is empty. Okay, so I'm in. Right, so next is you can log in to the Mikrotik. So Mikrotik is you can do telnet. Okay, so telnet to 10.30.1.117. Okay, and then 20xx. So we have 30 routers here. Okay, so you can choose what you want. So if you want to log into router 1, you can type here 01. If you want to log in 02, you can put 02, 03, or 04, or whatever. Okay, so 01, I can log into 01 and then press enter. Then here's my Mikrotik. Okay, so there is no GUI, guys. Hopefully you can learn something here. Okay, so you can see interface print. Okay, so we have interface, and then I can set system, identity, set name, router 1. Okay, so this is the router 1. So others, please, you can join my session here. You can also join. You can also log into router 1, but there will be a clash on that. so that we will trying to connect. We'll try to get the control of that routers. If you type something and then I can see it. Okay, so please try. Hello, can you guys see that? Okay. Okay, if you want to quit, and then you have to press Control and then a square bracket, left square bracket, left, right square brackets, and then quit. Okay. Also, you can log in here. Yeah, somebody is accessing the router one. Great. Okay, I will share my screen. Yeah. Hopefully it's big enough so that everyone can see. Come on, others. Can you have you log in to to the routers? Well, I can see some of you already log in. I can see 1, 2, 3, 4, 5, 6. Yeah, 6 people. So I can see some of you already log into router 1. Thank you. Well, what you can do is you can use Q. Q is simple, and then print. Okay, so nothing here. And then this is our IP address. I'm sorry. // IP address print. Okay, so no IP address. Wow. Yeah, we can use yeah, more and more people are coming here. Okay, please do telnet to the to the oh, I forgot to mention. Okay, so do telnet. This is the IP address 10.1.10.30.1.10.30.1.117 and then 20xx. Okay, so yeah, that's how you log into the Mikrotik routers. Sorry, we don't use Winbox here. So, for example, IP neighbor print. Oh, lots of them. So I will use IP address on IP address at on address 192.168.86.1/24 interface on Ether 6. Okay, so please do so. So right, so if you are using router 1, okay, so I will set up an IP address on Ether 6, right? My IP address is this and ends with .1. So that means I'm router 1. So if you're router 2 and then you put here router 2. All right, so please log in and then set up your own IP address, please. Okay, I can see some of you already log into router 2. Okay, that's good. Right, so I can see, I can ping 192.168.86.86. So nothing, timeout, nothing here. Ether 6, okay, Ether 6. So if you want to set up a, actually we can do a bandwidth test here. Bandwidth test against the router 86, right? Oops, looks like it has a problem. Okay, that's not. Okay, so I can ping router 6, yeah. I can do a bandwidth test, tool bandwidth test. Okay, so bandwidth test on address 192.168.86.86. Okay, it's connecting. And this is how it looks like. Okay, so maximum is 1 Mbps, right? So the maximum, because we want to avoid the CPU, so maximum speed here, only 1 Mbps, right? So TX, RX, can do direction both. So it means that we will do receive and transmit, right? So we can do TX. TX is 1 Mbps. RX is 1 Mbps. Okay, cool. Now, so with Ethernet you should use, and then you should configure an IP address on Ether 6. Okay. Okay, 192.168.86.x/24. X is your router number. So that's how it looks like. So I will do Q simple at name router 86. Okay, and then target is 192.168.86.86, right? So this is /32. Okay, what else do I need? Max limit. Max limit is upload and download. So for example, you can use 100K slash, for example, 101K down. Okay, so this is how you write. This is up, this is down. Okay, and then that's it. You can check Q simple print. Okay, you can see here. This is up, this is down. So up means for my side, it's gonna be the upload, and 110 means the download. So we can do the bandwidth test again, and then we check. So it works. Okay, so as you can see, RX current, okay, 96 kbps. That means that it's 100 kbps. So this is TX. TX means 100, 110, so it's almost 110. RX means the 100, yeah. Okay, so this is download. Oh, so yeah. So upload. So sorry, it's the opposite, right? Yeah. Sorry for that. Yeah, it's the opposite. Well, so that's how you do the bandwidth test. Sorry, we don't use Winbox here, so I just want to show Mikrotik without Winbox. So it looks cool, right? It's like the one in the movie, typing with the console. Right, thank you very much. We already 2030, 8:36 now, so it's more than 1 hour. Thank you very much. We really appreciate your coming here. Uh, there will be a next webinar in the future. Okay. And then if you are interested, we have a workshop regarding traffic control and other topics as well. You can check it in our schedule. And then at the end, this is end of the slides. We really glad you are coming here. We hope that you get the benefits of most benefits of our webinar from our, and yeah, if you don't mind, please submit the feedback so that we can improve ourselves. And if you have topics that needs to be discussed in the future, you can type here in the group chat. Okay. Right. I have one question here. Which queue type is recommended for dynamic user? I will use the PCQ. Okay. Here's the PCQ. Right. Because PCQ can divide the bandwidth dynamically. For example, you have 10 Mbps and then only one person is online. So that 10 Mbps will be shared to that particular person. Okay, so if there are 3 persons, it's going to be 10 Mbps divided by 3. And then we have 5%, 10 Mbps divided by 5. Right, so hopefully it answers questions. Right, thank you again. Thank you again for coming. Hopefully you can get the most benefit from this webinar. Okay, don't forget to submit your feedback so that we can be much more better. The slide will be available in the slide will be available in the website sometimes, yeah, and the recording as well. Okay, right. So I think that's all. Thank you very much, and then see you in the future.